All right, welcome to topic number 12, more on functions. So in this particular topic, I want to go over how we can evaluate functions at a specific value. And we also gonna evaluate functions using algebraic expression. All right, so let's do the value first. Evaluating function at a very specific value means we're gonna find the y value. Most of the time, this means find the y value when given any x value for the function. Now we can do it vice versa. We can say we can find the x value if I give you any y value. All right. So you actually done something like this before. Whenever we substitute a number for a variable and then work it out, okay, that number we substitute is actually the input or given an x value of a function. The answer we get after we simplify it, after we substitute and simplify it, most of the time those are the y value. Okay. Case in point. If I have an equation on the line, let's say y equals 2x plus 3, and then when I substitute 0 for x, right, that would be y equal to 2 times 0 plus 3, so y equal to 3. See, your input an x value, your output a y value. But sometimes we also say, okay, we can choose a number for y and solve for x. Okay, so this thing can go vice versa. But calculator, when we do this thing on the calculator, your input is always going to be the x value. Your output is always going to be the y value. Okay. So that's why we call the y value the dependent variable, because the y value are depending on what your input is, depending on what the x you put in. Okay. So we can evaluate a function by hand. Okay. Substitute value into the function and then work it out. We can also graph it and use a table to help us to find these y values. That's assuming if the x value is an integer, right? Positive or negative. Now, if the x value I substitute is like a decimal or a fraction, okay, then what we can do is using this feature called second trace. If you look at the word trace right above it, it's the word calc. So if you press second trace, that means you're doing second calc. Choose number one value, and you're gonna enter an x value. Whatever you enter, press, then whatever you put in, then press enter. It will output the y value for you. So if I want to know, okay, do you remember this was my original parabola, right? X squared. So if I want to find out, I wonder what 1/2 is, right? 1/2 or zero point 0.5. You enter it and you press enter. It tells you when x is at 0.5, the y value is 0.25. Okay, it's that quick. So remember, the table only displays integers. Okay, the table only let us see the input of integer x values. But if my input is going to be decimals or fractions, I can actually use the second cal feature. Okay, real quick, tell me what the answer is. So let's give that a try. Okay, I'm going to do this one by hand. Then I'm going to actually put in a calculator too. Okay, what I mean is by graphing it. All right, let's find -4, f of -4. So that means I'm substituting -4 for x, for every x that I see. It'll be there and there. All right, so f of -4 is equal to -4 plus 2 normally times x, now 2 will times -4, minus normally x to the third, now you will minus -4 whole thing to the third. Every time we substitute a value into the equation or function, always make sure the value is inside the parenthesis. All right, so the first term is -4, right? Second term, +2 times -4 is -8. Okay, this is the third term. This third term is -1 times -4 whole thing to the third power. So -4 to the third power is -4 times -4 times -4, which is -64. But this negative 64 times by the negative 1 will make that 64 positive. All right. Negative 4 to the third means negative 4 times negative 4 times negative 4, which is negative 64. But this term is negative 1 times, right? Times the negative 64 will make it positive. So this is actually 64 minus 12. 64 minus 12, because negative 4 minus 8 is negative 12. So that'll give me 52. All right, in the calculator, you have to punch it in under y equal negative 4 plus 2x minus x to the third. Okay, I'm gonna graph it. All right, you see my y value is 52, right? Okay, my y value is 52. So quickly go to my table, go up to find x equal to negative 4, y is 52, no problem. Now I'm gonna find my answer, go to second calc, number 1. And my input is negative 4 for x, and my output, press enter, is 52. There you go. All right. I don't think, like, for example, this window is from negative 10 to 10. So I don't know if I can put like a 20 or something. If I input 20 for x, which is outside the window, I don't know if, see, it will not do it. Okay, is everybody okay? So remember, your window is set up to be, oops, your window is from negative 10 to 10. So you can only input from negative 10 to 10. Otherwise, you will need to expand your windows in order for you to actually what? In order for the calculator to find the answers. All right, so I just want to show y'all that real quick. I'm going to do this one by hand first. So, by the way, what kind of function is this one I just drew? What type of function is that one? That is a what? Cubic function, right? That's a cubic function. This is a square root function. Square root of negative x plus 3 minus 2. So f of 7. I remember square root function was something like this. Square root of negative 7 plus 3, and then minus 2 on the outside. All right, negative 1 times 7 is negative 7. Negative 7 plus 3. So this is going to be square roots of negative 4. Oh, yep. Minus 2, which you know, square root of negative 4 is 2i. So if I want to find this answer in the graphing calculator, I will never be able to find it, because the I means complex number or imaginary number. It does not exist on the regular x and y axis. So if you actually set what's inside the square root equal to 0 and solve for x, you will notice that x is actually equal to 3. So that can be where my domain starts or ends at. And I think this one, square root normally look something like this. But since I'm actually dressing it up, my square root function, you might not go where I think it goes. Negative x plus 3 minus 2. It's actually going what? The other way. So anything to the right side of x equal to 3 does not exist. Okay. So you can say not a real number. So that one we cannot find. All right, this one, find f of 4. So I'm gonna substitute 4. I'm gonna do this by hand, now we'll put it in the calculator. All right, substitute 4 for x, right? 2 times 4 minus 1. So this is 0 over 7. 0 divided by anything is 0. So f of 4 is equal to 0. I'm gonna graph it. All right, two term on the numerator, put them in the parenthesis, divided by two term in the denominator, put in the parenthesis. I'm gonna graph. So this is my rational function looks like. I'm gonna go to table and find x equal to 4. And that's actually y equal to 0. So can you tell me again where on the graph y is equal to 0? Where on the graph y is equal to 0? Y are equal to 0, got to be on the what? On the x-axis, right? So that point, when x equal to 4, y equal to 0, that point must be the x-intercept. Okay, so that must be the x-intercept. So later on in different topic, I will show you. Okay, here is a rational function. How do you go about finding the x-intercept? X-intercept means find x when y is equal to 0. Okay, so that's what that means. So this function right here, square root of x plus 2. I want you to solve f of x equal to 0. What does that mean? Solve f of x equal to 0. Well, remember, f of x also means y. So I want you to solve for x when y is equal to 0. Okay, I want you to solve for x when y is equal to 0. That's what this phrase means. So that f of x is y. So now this y will now be replaced with 0. The whole thing will become 0. The whole f of x will be replaced with the number 0. So now the equation is 0 equals square root of x plus 2. And we need to solve for x. We can solve for x by simply, since I only got two terms, I can square both terms. Because square and square root cancels out. So that will leave me with x plus 2 equal to 0. All right, since x is positive, I'm going to move my positive 2 over. So x equal to negative 2. There you go. So solve for y, f of x equal to 0 means find x when y is equal to 0. And that's exactly the same thing as finding the x-intercept. So every one of these functions, if I'm looking for x-intercept, I will simply just replace f of x with a 0 and solve for x. All right. Now, problem like this one will be difficult to do on the graphing calculator. To start out with, it's not, graphing calculators are really designed for you to input an x value and output the y value, not vice versa. Okay, that's why I do this one by hand. But now since you know the answer is 0, once you graph it, you know what you're looking for. Okay, but if we do this problem just straight up from using graphing calculator, then sometimes it can be difficult to find the answer we're looking for if we actually know what the y value trying to find the x value. All right, let's talk about this. This evaluating function with an algebraic expression. These formula means something. Okay, these formula means something. In other classes, especially in calculus. These are calculus formulas. All right. I'm just using these formulas to kind of do some evaluating functions. So let me show you how to do these. Okay. So here I'm giving you a function called g of x, which is equal to 3x minus 4. And I want you to use this function to simplify these two formula. So right now at the beginning, you have no idea what this answer is going to look like. Okay. And that's one of the harder things about these problems is you're giving a formula, a function, you need to simplify it. But where did you stop at? Okay. So that come with experience, really. That really come with experience. So we need to substitute this function in here. This part right here, g of x. This g of x is the same as this g of x. Okay. So now what is g of a? So let me do this on the side. G of a simply means I will substitute a into my function g of x. G of a means instead of having x for variable, I would now substitute a into what? Into my function g of x. So that will give me 3 normally will times x. Now 3 will times a minus 4. So when you see g of a, you put this in. When you see g of x, you substitute with that. So g of x, 3x minus 4. Now we're minus g of a. G of a is this. There's two terms representing one g of a. So we put them in the parenthesis. Whole thing still over x minus a. So once you write it out, once you first write, you write it out, the function. Now, where does this problem end at? This problem will probably end up at, based on the experience, it's probably end up with x minus a down here being canceled out. Okay. And that's actually what we're trying to do. This is a rational expression right now. So we need to simplify and see if the denominator and numerator can somebody can be canceled out. So now the next step is, okay, simplify the numerator. So this negative means -1. We'll now do a distribution. And that gave me 3x, -4, -3a, and +4. Whole thing over x minus a. Now the -4, +4 cancels out. I know I end up with 3x minus 3a over x minus a. So remember when we reviewed on how to simplifying rational expression, especially when we did the adding and subtracting rational expression, at the end, you're always going to try to factor your numerator to see if it can see if any factor can be canceled with the denominator. So it turns out my numerator can be factored. The greatest common factor is 3, so that leaves me with 3 times x minus a. The denominator, there's nothing else to factor out other than 1, so we put them in the parenthesis because we got to make sure it's one term over one term before we can cancel them out. So my answer is 3. So what this problem eventually become, what this formula, this whole entire process eventually become is a way to do derivative in the calculus course. All right, let's try this one. Same function, 3x minus 4. Okay, so g of x, see the formula had g of x right here. Okay, so when it says minus g of x, I will actually put that in. So what's g of x plus h? Well, let me work that out. Remember, let me write it. G of x is 3x minus 4, right? So g of x plus h simply means I will substitute x plus h for x. Substitute x plus h for x. So whenever I send x, I will actually put it, or I will actually write x plus h. So 3 normally times x. Now 3 will times x plus h. And that's two terms, right? Two terms for one variable I'm substituting. Got to put in the parenthesis, minus 4. All right, I'm going to simplify this real quick. That gave me 3x plus 3h minus 4. So whenever you see g of x plus h, I will put that in. All right, so my first term on the numerator is now going to be replaced with 3x plus 3h minus 4 minus g of x. G of x is 3x minus 4. So I will put them in the parenthesis, whole thing over h. All right, -1, do a distribution again. So that's 3x plus 3h minus 4 minus 3x plus 4, whole thing over h. So you're like, okay, again, we got a rational expression. We multiply it out. We're going to simplify the numerator. And somehow, maybe that h can be canceled out down there. All right. So I think we got lucky. The 4 cancels out. The 3x cancels out. Haha, we end up with 3h on the top. One term on top, 3h over h. So when the h cancels out, my answer will simply be 3 again. Okay. All right, so that's not too bad because g of x originally was a linear function. Linear function is always a little bit easy to work with. Now, if we go out to quadratic functions, then it gets a little bit trickier. All right, so I'm gonna do g of a again, okay? G of x is that. All right, so I know I gotta put in front of g of minus g of a. So I'm gonna do g of a right here. G of a. All right, substitute a for x. So wherever x I see, I put an a in it. So that'll be negative 5a squared plus 2a minus 1. All right, g of x first. Negative 5x squared plus 2x minus 1 minus g of a is those three terms. Holding over x minus a. So very similar to the previous problem we just did. Gotta somehow trying to cancel out with the x minus a down here. All right, next step, we will distribute so I can begin to simplify my numerator. Negative 5x squared plus 2x minus 1 stays the same. That's a positive 5a squared. That's negative 2a and positive 1. Holding over x minus a. All right, 1 cancels out. 1 and negative 1 cancels out. Now what I got myself is negative 5x squared plus 2x plus 5a squared minus 2a. Now, factoring by grouping comes back because I got 4 unlike terms on the numerator. And none of the 4 term has the greatest common factor. So this got to be a factoring by grouping. I got to factor in order to cancel out with the x minus a in the bottom. But how do I go about factoring by grouping? How do I group them? The biggest hint is right here in the bottom. Remember, the bottom want to have x minus a, right? So that means the way how I group them I must group x and a together. So I'm gonna group those two square terms together. Then I'm gonna group these two terms together and I'm gonna make sure the x is in the front. So let's do this on the side. The factoring by grouping here is the key of this example. If I will group the first and the third, the greatest common factor needs to be negative 5. Why? Because this x is a positive. I don't want my x to be negative. So I factor out negative 5. So if I factor out negative 5 from negative 5x squared, that should give me positive x squared. If I factor out negative 5 from positive 5a squared, that should be negative a squared. Right? Negative 5 going to positive 5, negative 1 times. Between 2x and negative 2a, I need to factor out a positive 2 because that will automatically give me x minus a. All right, factoring by grouping. What's inside the parenthesis does not match, Mr. Chan. Mr. Chan, how do I make the parenthesis match? But take a look at what this is. That right there is a difference of squares. So remember, the plus sign right here means this in front of it is one term. So this one term can actually be factored again. So this is a difference of squares. So I can say that's a negative 5 times x plus a times x minus a. Still plus my 2 times x minus a. All right, I'm still having 2 terms. So now what's inside the parenthesis matched the The minus a matched. Oops, take me all the way back to the top. So that's my greatest common factor. So once I factor out the greatest common factor, what's left for my first term? Go in the second parenthesis, right? What's left for my first term? Negative 5 times x plus a. What's left for my second term? Just a positive 2. Whole thing over, still x minus a. All right, so now this numerator is only one term now, right? If I factor out the greatest common factor 1 between x minus a, I can put that in the parenthesis so that these two can cancel out. And that would be my answer. Okay. All right, let's try this one. G plus x, G of x plus h again. So I'm gonna write my function right above it. G of x is negative 5x squared. All right, so let me simplify g of x plus h first, and then we can substitute into this formula. So now I'm going to replace every x with x plus h. So that will be negative 5 times x plus h, whole thing squared, plus 2 times x plus h minus 1. All right, let's simplify this. Okay, so I got three terms here. This is perfect square binomial. So when we reviewed perfect square binomial, we said a plus b whole thing squared is equal to a squared plus 2ab plus b squared. And we, so perfect square binomial. So what you want to do here is actually apply perfect square binomial because you got so many terms. You don't want to write this more than what you need to. So your a is 8x, your b is h. So a squared plus 2 times your a times your b, that would be 2xh, plus your h whole thing squared, right? B squared means your h will be squared. So this part will give you these three terms. It had to be distributed by this negative 5. So now once the negative 5 distribute, I get negative 5x squared minus 10xh minus 5h squared. All right, positive 2 times x plus h is the next term. Distribute, give me positive 2x, positive 2h, still minus 1. And there's no like term here to combine. So g of x plus h is all that. So we write all that minus g of x. Okay, so g of x plus h, all that. Minus g of x, which we'll substitute for negative 5x squared, plus 2x minus 1, holding over h. All right, there's a big mess up top. Let's distribute, and so we can see who we can combine. Negative 5x squared minus 10xh minus 5h squared plus 2h minus, excuse me, negative 1 times negative is positive 5x squared. Negative 1 times negative 2, positive 2 is negative 2x squared. Negative 2x, excuse me. Negative 1 times negative 1, positive 1. Holding over h. So who can I combine? Oh, the x squared cancels out. Oh God. The X cancels out. So now I end up with, I should have doing this right. 1, 2, 3, 4, 5, 6 terms. Yep. Did I miss something? Oh, -1. I missed my -1 right here. Sorry, 2h -1. I knew that didn't. Okay. So I messed. I didn't write this term right here. So this -1 and positive one should cancel out too. I knew I left out 110 when I was saying it. All right. So only thing left on top is basically negative 10xh minus 5h squared plus 2h over h. So now this is not that bad because the greatest common factor in my numerator is h. So if I factor h out, then negative 10x minus 5h plus 2 will be in the parenthesis over h. So now the h can cancel out. My answer will just be negative 10x minus 5h plus 2. All right. So look kind of messy at the beginning, but a lot of things will cancel out. Okay. All right. So question number 1, consider the following function. Evaluate the function at the indicated value. And so all you gotta do is do this on the side. Substitute -1 in here, or if you want, you can graph this function and then go to the table and find -1, and find -1 for x, see what the y value is. So all you gotta enter on the homework is the y value. All right, question number 2. Okay, question number 2 is in steps. So this is exactly the example I just did up here. Okay, but I'm doing this in steps. So the first thing I want you to do for question number 2 is substitute what the function f of x is into the formula. Okay, put this into the formula. So your answer will look negative 3x squared plus x plus 4 minus f of a over x minus a. All right, just put f minus f of a right here. Just enter f of a here, or write f of a, excuse me. This is on the handwritten portion. Now I want you to do this on the side like I did earlier. Okay, what is f of a? Well, substitute a for x, right? Substitute a for x and write down what f of a is for number 2. Then once you know what f of a is, I want you to write it back into the formula like I show you with the parentheses. Okay, then you will distribute. -1 will do a distribution, bring all the term to the outside first. Do not combine like terms. Then number 5, combine the like term on the numerator. And number 6, I want you to factor the numerator from 5, just like what I did here on the side. The factoring by grouping. Okay, different number, but same process. I want you to group the x squared term together, okay, and then group the x and the a term together, and perform your factoring by grouping. Okay, but I don't need you to cancel them out. Your final answer should look like this. I don't need you to cancel them out because it's obvious you know the x minus a will cancel out. So please show me the work on how you did the factoring by grouping. Okay, show me the work on how you did the factoring by grouping. You don't have to cancel out the x minus a. You know, you can just leave them like it is. The key part is the second parenthesis on the top. I want to see how you can actually perform the factoring by grouping the way that I did. All right. So that will conclude this video. Thank you for watching.